Here is a matching type question on general organic chemistry. Study the items in both columns carefully. Try to work out the matching before we solve it together. Let us first understand the key concept here. H-bond donor, a molecule that has a hydrogen atom directly bonded to a highly electronegative atom, NO or F, i.e., NH, OH, or FH bonds. H-bond acceptor, a molecule that has a lone pair on a highly electronegative atom, NOF, that can accept a hydrogen bond from another molecule. A molecule can be only a donor if it has NH, OH, FH, but its electronegative atoms cannot accept, unusual, but HF is borderline. However, in this classification scheme, the answer key places HF under donors only category B, meaning it is both donor and acceptor. Actually, rereading the answer, A, only donors, is equal to A, C, F, G, K, L, B, both donor and acceptor, is equal to B, D, H, J, C, no H bonding, is equal to E, I. Moving on to the next step. A, bicyclic tertiary amine, pyrrolizidine type. The nitrogen is tertiary, no NH bond, so it cannot donate H bonds. It has a lone pair on N, so it can accept H bonds. Therefore, it is an acceptor only. The answer key places it in A, only donor. Wait, re-examining, the answer says A includes A. Let me reconsider the question wording. Question A asks only as H-bond donors, but perhaps the intended meaning in this question bank is only as H-bond acceptors for A, or the labeling of ABC differs. Actually, looking again at the answer, A is equal to A, C, F, G, K, L, and B is equal to B, D, H, J. Let me reread the questions. A is equal to only donors, B is equal to both donor and acceptor, C is equal to no H bonding. This seems inconsistent with standard chemistry for A. However, given the answer key is ground truth, the intended interpretation must be A is equal to compounds that can serve only as H-bond acceptors, not donors, B is equal to compounds that serve as both donors and acceptors, C is equal to no H-bonding participation. Moving on to the next step. Reinterpret with corrected reading, A is equal to only acceptors, based on structures matching the answer. A, tertiary bicyclic amine, lone pair on N, no NH, only acceptor A. C, ethyl acetate, ester, lone pairs on O, no OH, only acceptor A. F, tetrahydrofuran, lone pairs on O, no OH, only acceptor A. G, cyclohexanone, lone pairs on C is equal to O oxygen, no OH, only acceptor A. K, N-acetylpyrrolidine, tertiary amide, lone pairs on O and N, no NH or OH, only acceptor A. L, diphenyl ether, lone pairs on O, no OH, only acceptor A. B, isobutanol has OH, donor, and lone pairs on O, acceptor both B. D, HF has FH, donor, and lone pairs on F, acceptor both B. H, cyclopentane carboxylic acid, has OH, donor, and lone pairs on both oxygens, acceptor both B. J, aniline has NH bonds, donor, and lone pair on N, acceptor both B. E, tert-butyl cyclopentane, all CH and C to C bonds, no heteroatoms, no H bonding C. I, bicyclo, 4.2.0, octane, cyclohexane fused cyclobutane, all CH and C to C bonds, no heteroatoms, no H bonding C. And for the final step. Why the question text says donors for A but the answer corresponds to acceptors? The question as printed likely has A asking only as H-bond acceptors, a transcription OCR issue in the problem statement image, or the question bank uses a different ordering. The ground truth answer is consistent with A is equal to only acceptors, B is equal to both, C is equal to neither. Therefore, the correct answer is A, C, F, G, K, L, B, B, D, H, J, C, E, I. Therefore, the correct matching is A matches A, C, F, G, K, L, B matches B, D, H, J, C matches E, I.